All right, this is the normal curve scenario. What we're going to do, you can watch the video here by clicking on the click here. Of course, you got to put your name in. The purpose of this activity is to give you concrete experience necessary for you to thoroughly understand and apply the concepts of the normal distribution, normal curve, empirical rule, and apply those to practical problem solving. We're going to categorize data, make distributions, list the elements of a normal curve, and then solve the normal curve using the normal distribution function in Excel. The example we're going to use for the normal curve comes from floorboards and how that data would be arranged. What you see here is three different floors. You've got a floor that mimics normally distributed floorboards, random distributed floorboards, and then uniform distributed floorboards. And here's how the data works. On the left-hand side, you see normally distributed boards, but they're all stacked up. On the right-hand side, we organize them by putting them into a bag. Here's how a stack of normally distributed boards would look. And notice it's slightly different than the randomly distributed boards. You can kind of see some differences there. Of course, the uniform boards, totally different. So the question is, what are the differences between random and normal distribution? If you notice here, we've got the boards stacked in 6 different buckets. And basically what you want to do for a grouped frequency distribution, we've got the boards in the teens, 20s, 30s, 40s, and 50 centimeters long. If you notice, in the normally distributed, there's a whole bunch of the 30s, fewer of the 40s and the 20s, and then fewest of all of the 20s. I'm sorry, these are the 30s, 20s, fewest of the teens and the 50s. For random distribution, there's an equal number, approximately, of each of the 5 different grouped categories. What you're going to do is to make a statistical analysis of the boards using Excel. On the left-hand side, you have the lengths of all of the normal boards. On the right-hand side, the lengths of the random boards. So what we're going to do is to use Excel to find each of these values. There is a minimum function. It returns the smallest number of a set of values, but we're actually going to use the quartile.inc inclusive category for our data. And I'm going to show you how and why we're going to do that in just a second. So the first thing we want to do is to highlight the data that we want to be included. So there's our array in the first row. And which quartile do we want? We want the 0th. Why? Because it says the minimum number is 0. First quartile is 1. Second quartile is 2. Third quartile is 3. And fourth is the maximum. Now, the other thing that we want to do is we want to have the array be these numbers with a $ in front of them. What that means is that the values don't change, and I'm going to show you why we don't want the values to change. We're going to pull that value down all the way through Q1, Q2, Q3, and maximum, because then when we go to the second value, if you notice, it still says C213, K275. The third one, C213, K275. So it didn't change the values when we pulled them down. But what we do need to change in the second one is we need to change it to Q1 because it is the first quartile. Now if you notice, the shortest board is 10 centimeters long. The first quartile board is 28 centimeters long. Second quartile, or median, as it says here, is 35 centimeters long. Third quartile is 42 centimeters long. And then the maximum board is 60 centimeters long. Oops, 4, excuse me. Is 60 centimeters long. Then let's do the same thing for the random boards, equals quartile, inc, and our array of data. And we want to get each of these values to be, press F4, and you get the $sign in front of them, which means it won't change when we pull it down. And so we go through and we change in the Q1, we change it to the value to 1. In Q2, or the median, we change it to 2. In Q3 to 3, and then for maximum we change it to 4. So those are our different Qs. And if you notice, those numbers are part of the box and whisker data. And so let's look at how the box and whisker looks. If you notice, here's the box and whisker that was developed from that data. You've got the shortest and the longest boards, so the whiskers are the same in each case. The random boards are more spread out. The normal boards are closer together. In the normal boards, the median, the Q value, is right in the middle, whereas in the random boards, in this case, it's a little offset to the left. It could, of course, be a little offset to the right. That's the nature of randomness. Equals average, and we want to find the average of these boards. And do the same thing over here. And as we said before, one thing that you'll notice is that Q2 is really close to the average in both cases. That's not always necessarily so. On the normal boards, it's always true that the median and the mean are the exact same value. And finally, the standard deviation of the population, STDEV.P, and we want to do all of the lengths there. And standard deviation of the population of the random boards. Oops, I didn't do that right. Equals STDEV.P, population of the random boards. And the other thing that you'll notice is that the standard deviation is larger on the random boards. How is that illustrated? Well, in our box and whisker plot, the box is longer in the random distribution than it is in the normal distribution. Finally, we're going to make a frequency chart so that we can make a histogram. Remember, a frequency chart, the first thing you do is you highlight the cells that are next to your bins. And then you type equals frequency, parentheses, and we want the frequency of these data using these bins, and our bins are right here in the middle. And make sure you highlight that first one, that is the 0 value also. And when you are done, so equals frequency, parentheses, you have to highlight the data array, and you have to highlight the bins, comma, bins. When you are done, after you close the parentheses, press Control, Shift, and then Enter. Yeah, don't go to that FX button because that'll screw you up like it did me. Do the same thing over on the other side. Highlight all the bins that you want, equals, and then type frequency. And we want the frequency from all of those data points. And the bins are right here in the middle, 9.9 down to 60, close parentheses, and now Control, Shift, Enter, and we see we got all the points. For our total, we're going to type equals sum of those values. And I'm going to copy this value, Control C, and paste it over here, Control V. So if you notice, both sets have 567 boards. Now we're going to add a a histogram on both sides. Step 1, highlight the data. Step 2, go to Insert Column Graph, and you see the data there. Step 3, go to Design, and we want to click on the one that looks like our data. It's the third one down. Put in the chart title, Normal. Change the colors, and we change our fill to orange. And then the last step, if you notice, the lines are together here on the one that we made, or that you're supposed to copy. So go to Format Data Series and change the gap width to 0. And now your graph looks approximately like mine. There is one more difference, and that is, if you notice down at the bottom, it lists the frequencies that we have in our chart, and the one that we just finished with has 1, 2, 3, 4. It has them by categories. So the last thing we want to do is move it over to the side, and I'm going to show you why in just a second. And then go to Select Data, and we're going to pull that up a little bit and edit the horizontal categories, because we actually need to get those horizontal categories from our frequencies. And now, if you notice, the numbers down here changed to match our example. Over on the left-hand side, we're going to do the same thing. Highlight our data that we want. Insert a column graph. Change it to the third one down. Change the title to random. This time we don't have to change the color. We do have to merge the values together. Right-click, select data, edit the horizontal category, and get the lines close together. Format Data Series, close the gap. All right, and those two match the ones that are above them. To get the points, the only way you get that is to type yes for the normal and yes for the random, and then I'll look at them to make sure that you have the title, the labels, correct data heights, and clarity of presentation. The thing that I want you to notice is the normal data has a peak in the middle. The random are all the same length. That is another way to illustrate what we found here. The reason the normal data was taller in the middle is that it had more frequency. And if you notice our stacks, we had more frequency of the middle section, fewer of the 2 on each side of it, and then fewest of the ones on the end. Our random data were the same number of boards of each length. That's the same illustration that you see listed here. 219 boards were in the 30s. 107 boards were in the 30s on the random data. All categories had the same. If you notice, in each case, there were no boards shorter than 9 centimeters, or 9.9 centimeters. Okay. Here's another illustration of those exact same floorboards that we had pictured here in the buckets, only this time they are stacked from shortest to longest, and it's an ungrouped frequency distribution. Ungrouped means each value is represented frequency is the number of boards, and a distribution is how they're laid out. So we've got shortest on the left, tallest on the right. Most of the boards are right in the middle. That normal data that you see here is pictured in this graph on the left. Shortest boards on the left, tallest boards on the right. Most of the boards are the 35, 36, 34 category. In the random distribution, there's no pattern that develops. Because of that, we can't make any rules about the random distribution. We can about the normal distribution. Normal means it follows the rules, and here's how the normal distribution always looks. Right in the middle is the average and the median. One standard deviation each way is halfway down the slope. Two standard deviations each way is twice as far away. On the random dispersion, the average is not necessarily right in the middle. One standard deviation each way in this case gets us to 19 and 49, and that's because 34 and our standard deviation, if you remember, was 14.7, almost 15. So one standard deviation each way gets us down to 15 and up to 49. We can't go two standard deviations over here because minus 15 more gets us down to 4, and the shortest board is 10. 15 more gets us up to 63, and our longest board is 60. Same thing over here on the normal distribution. We didn't have any boards that are 3 standard deviations away. If we would have made more boards, we would have had 3 standard deviations away. It's just we ran out of boards when we got to one 10-centimeter long board. They show z-score calculations, normal curve calculations, and we're going to use the normal distribution function. We are going to use the cumulative distribution function and then subtract to find our values. Let's look at the example that we see pictured here. What decimal portion of the boards are between z negative 1.2 and 2.3? By looking at the diagram here, it should be around 80%, between negative 1.2 and 2.3. So let's see how we go about doing that. We would type equals normal.distribution, and our value that we want for the upper portion is 2.3. The mean, it says, is 0, and the standard deviation is 1. And we want it to be cumulative, so we have to type true. And when we do, we get 0.989. Then for the lower portion, our lower limit equals normal.distribution, and we're going to take our value, which is negative 1.2, and the mean is still 0, and the standard deviation is 1, and our lower limit will be, our cumulative is true again. And now to find the area, what decimal portion is the area? It's going to be the upper limit minus the lower limit, and we get about 87%, which is what we said. By diagram, it should be about 80%. 87, we were pretty close, weren't we? So, if you are confused about what to type, in each one of the cases, you can see what to type by clicking on the pink area. Let's go down here. In the normal curve, what decimal portion is less than the mean? So equals normal.distribution, and we want less than the mean, which is 35. Oh, I'm sorry. Our mean is 0. Our standard deviation is, our mean is 0. Our standard deviation is 1, and we want true. So less than the mean, we get 50%, which kind of makes sense. 50% of the boards will be less than the mean, within a half a standard deviation of the mean. So we have 2 normal distributions to cover here. Normal.distribution, and we want from positive 0.5, and our mean is still 0, and our standard deviation is 1, and true. Subtract one standard deviation less than the mean, normal dot distribution, parentheses, negative 0.5, comma, 0, comma, 1, and we get, oops, oh, we have to put a true in here first, forgot about that, comma, true, we get 38%. Now, this is much more complicated math than we had when we used our calculator. And the reason for that is our calculator automatically, I got to make the calculator smaller. Our calculator automatically fills in the values that we need. Remember, we go mode, and we want a distribution, so I did arrow down 1, 3. And we want normal cumulative distribution, number 3. Our lower limit is negative 0.5. Our upper limit is positive 0.5. Standard deviation is 1. Mean is 0. And we get 38%, which is exactly what we got using Excel. I just like using the calculator better because you don't have to do all those calculations. Within 1.2 standard deviations of the mean. So equals, parentheses, normal dot distribution, parentheses, our value, so positive 1.2, comma, our mean is still 0, our standard deviation is 1, and true. Subtract the value negative 1.2, our mean is still 0, standard deviation is 1, and true. And when we do, we get 0.769, 2.5 standard deviations. I'm going to copy the one that we just got done with, drag it down, and then change the values in here. We want it 2.5 and negative 2.5. Makes it just a little, the math go just a little bit faster. I'm going to do the same thing for the rest of them too, and then just change the values when I get to them. Okay, is less than negative 1.3 standard deviations. So our top value is negative 1.3 standard deviations. Our bottom value is negative, I'm going to use 1,000 because that's a lot of standard deviations away. And we get about 9% is less than negative 1.3 standard deviations, is more than 1.5 standard deviations. So now I'm going to make the top a positive 1,000 standard deviations, and the bottom is going to be negative 1.5. Is between negative 2.1 and 3.5. I should have been showing you the picture each case, and I didn't. So I'm going to do the picture for this last one. Okay, the first thing that I do is I have my standard normal curve, and I want to go from, it says here, go from negative 2.1 to positive 3.5. So from here, negative 2.1 to here, positive 3.5. So we want to know how much area this is. So we do the top first, then subtract the bottom. Our top value is 3.5. Our bottom value is negative 2.1. And when we get done, we get approximately 98% of the boards are between those two values. Which, if you look at the picture, you can see that's going to be true. There's very few boards. It's only these 3 right here that are outside that area. What do we do if we have the actual boards? In order to do that, we need to have the mean, which we had calculated before as 35, and the standard deviation, which we had calculated before as 9.627. Now, among the normally distributed floorboards, what decimal is the mean length of the board? So equals normal dot distribution, open parentheses, our mean, which is 35, comma. Now it's time to work with the boards that we have as our chart. The first thing we want to do is to find the mean, which we had up above. So we're going to type equals, and our mean value was farther up, and the standard deviation was right below it. So get those two values, 35 and 9.627. Then we're going to figure out what decimal portion is the mean length of the board. Well, how long is the average, in other words? So we would say the average is that 35. Oops. And the standard deviation is 0.9627. Okay, we want the boards that are one standard deviation below the mean. Well, the mean, so we're going to take the 35, and then since it's one standard deviation below the mean, it's going to be subtract a standard deviation. I'll show you how that looks in the picture. So we have the mean is 35, subtract one standard deviation, you're around 25. And it comes out to be exactly 25.37. 2.1 standard deviations above the mean, so we're going to take the mean, equals the mean plus, and we want 2.1 standard deviations, so 2.1 times the standard deviation, and we get 55.21, which kind of makes sense because here's one standard deviation above, two standard deviations above, so 2 and a little bit more makes 2.1 standard deviations above the mean. What decimal portion of the boards are shorter than 18 centimeters? So the first thing we want to do is to get our picture, and we're dealing with the boards, it says, that are shorter than 18 centimeters. So we want these boards right here. What decimal is that? I'm going to say about 15%. No, less than that. 5% maybe? 0.05. Okay? How do we go about doing that mathematically? Well, we've got 18 centimeters is this board. Let's say the shortest board is 0 centimeters. Maybe negative 1,000 centimeters. Then for sure we've got all of the boards included. Okay? So, let's go to our chart. Equals normal dot distribution, parentheses. The value that we start with is 18. The mean is this value. The standard deviation is this value. And we want true. True. Subtract the shortest value, which is normal dot distribution, and negative 1,000. The mean is still 35. And the standard deviation is 9.6, comma, true. Now, actually, that shortest one is 0. So if you look at our picture again, we know this has 0%. So whatever our value is actually the length of the 18 centimeter boards. So we could have gotten the exact same answer by just saying, what is the cumulative frequency of 18? And we get 3.8. What number of them are between 21 and 44 centimeters long? The first thing I'm going to do is solve it on our calculator. 21 to 44. So I'm going to do mode, arrow down one, distribution, normal cumulative, number 2, and our lower limit is 21 centimeters. Our upper limit is 44 centimeters. Our standard deviation is 9.627. 9.269, and our mean is 35. And it comes up with 75%. Let's look at the diagram to make sure that we've got it right. So we want to go from, I got to get a new diagram. So on the diagram, we're going to be from 21 to 44 centimeters. From 21 here to 44 over here. What percent of the chart is this? Well, it looks like about, 75%, somewhere around there. Okay, let's do the math. Equals norm dot distribution. We do the upper limit first, 44, the mean, 35, the standard deviation, 9.629, oops, comma, true. The lower limit is normal dot distribution, 21, mean, 35, standard deviation, 9.629, oops, comma, true. And we get the 75% that we got on our calculator. What portion of them are longer than 39 centimeters? So we want the ones that are from 39 here forward. So all of these. I'm going to make the longest board positive 1,000. Okay, so it'll be 1,000 minus 39. So equals norm dot distribution, 1,000, mean, 35, standard deviation, 9.629, true, minus the 39, normal dot distribution, 39, and the mean is 35, standard deviation 9.6269, true, and we get about 33%. We have some values that we're missing someplace. What didn't we fill in? 28.3. Good. Let's make sure we got all our points. Okay, looks like we're done. And so our score should say 30 points. Yours will. I'm not sure why mine doesn't, but I'll fix that in the video.